Welcome to the deep dive. We skip the noise and get straight to the heart of fascinating ideas.
We extract the key insights for you, so you get tailored knowledge without the overload.
And today we're looking at something, well, surprisingly deep hidden in basic math.
Our mission here is to really explore the philosophical weight behind what mathematicians call strict and wide-order relations.
We're drawing on our own conversation, sort of unpacking the thinking behind these symbols.
And question for you is, have you ever stopped to think that maybe these mathematical tools aren't just abstract, but actually reflect fundamental ways we understand the world?
Yeah, how we grasp change, stability, maybe even our own place in things. Let's dive in.
Okay, so when we first talked about this, you insisted we start with the philosophy, not the math definitions. Why was that so important?
Well, I felt then, and I still do now, that these symbols, and they aren't just arbitrary conventions. They feel like they tap into something really basic about perception.
How we make sense of relationships in the world.
Exactly. So the strict order and the wide order, they really represent two quite distinct ways of conceiving how things relate.
Okay, let's start with strict order then. You called it the logic of pure becoming. Can you unpack that a bit?
Think of it as a world seen only through the lens of difference. Nothing is ever truly identical to anything else in comparison.
So A is just false. It can't happen.
Right. It's inherently contradictory in this view. It really captures that sense of constant flux, constant change.
Like Heraclitus, the river guy?
Precisely. No one ever steps in the same river twice. Strict order embodies that feeling everything is always in process, always becoming. It emphasizes the lack of sameness.
Okay, that clicks philosophically, but can you give us a more, concrete example?
Sure. Think about evolution. We can meaningfully say Homo erectus, Homo sapiens. There's a clear, temporal, irreversible order.
Right, one came before the other in that lineage.
But saying Homo sapiens in that same evolutionary sense, it just doesn't work, does it?
No, it feels wrong. In that snapshot, they are what they are.
Exactly. So strict order is great for describing these kinds of processes where things change fundamentally and irreversibly.
Got it. Pure difference, constant becoming. So then what about the wide order? How does that contrast?
Okay, so wide order, the logic of identity in relation is fundamentally different because it allows for identity. It accepts sameness within a relationship.
Meaning A is perfectly fine. It's true.
Yes. It acknowledges that something can be equal to itself, even when you're placing it within some kind of order or comparison.
Interesting. Who does that remind you of philosophically?
It points towards Parmenides, actually. His whole focus was on being is the stable, unchanging nature of reality.
Ah, the counterpoint to Heraclitus.
Exactly. Wide order, by including equality, incorporates this idea of self-consistency, of things having a stable identity, into its relational structure.
Why do we need both? Is it just like mathematical convenience?
I think it's deeper than that. It touches on that fundamental ontological question about what reality is.
Okay.
Strict order is indispensable when we're talking about things that just don't go backward. Think about time's arrow or cause and effect. The cause has to come before the effect.
Irreversible processes. Got it.
And wide order.
That seems crucial for any situation where you have stable states or where identity matters within a group. Classifications, maybe.
Precisely. Or sets where some elements might be identical. Rankings with ties, like we said. It handles scenarios where sameness isn't just possible, it's part of the structure.
You had that metaphor.
Yeah.
The wind and the rock.
Ah, yeah. The strict is the wind that pushes forward, always changing its path. The wide is the rock that admits to being itself while resisting the wind.
I like that.
Ultimately, the choice between them really depends on what aspect of reality you're trying to capture, what you want to affirm or negate about identity versus difference.
Which really frames mathematics as, well, philosophy and symbols, like you said.
That's the goal, really, to see math not just as calculation, but as this rich language for telling philosophical stories about the universe. Why does 3F3 feel right, but 3-3 feel wrong? It taps into something intuitive.
It's like math itself distinguishes between, what did you call it? Being and becoming.
Yes. The wide order helps us grasp being, stability, identity. The strict order captures becoming, flux, transformation.
And equality within the wide order is like an act of recognition.
It is. It's acknowledging self-sameness. While strict inequality is about difference, about movement from one state to another.
Okay, this connects to something else we discussed, the paradox of identity. Can you elaborate on that?
Right. It sounds simple to say like a book being under itself in a non-strict sense. But Accepting that forces a choice, doesn't it?
A choice about what?
About whether the world is fundamentally pure movement, pure becoming, or if it's a structure that allows for pauses,
Huh.
for stability.
The concept of the pause. That seemed really significant. What is that pause exactly?
Think of the pause as the present moment, the now. It's essentially the equality part of the wide order.
Okay.
If time is just a relentless flow like Heraclitus' river, without a moment you can pin down and say, this moment is itself, then how do you even compare things? How do you make judgments about before and after?
The pause is what allows comparison. It's essential for judgment.
I think so. It gives you that fixed point. Without the present defined by equality, by that pause, past and future become kind of unmoored. It grounds everything.
How do the two orders, strict and wide, specifically relate to this idea of the present as a pause?
Well, with wide order, saying present, present, this instant is equal to itself that is hitting the pause button.
Yeah.
It creates the stable reference. Without that fundamental self-equality of the now, ordering time becomes conceptually very slippery.
In strict order, how does the present work there?
With strict order, you get the flow, past, present, future. But the present in that chain, it doesn't have that same anchor of self-identity.
It's just another point in the sequence.
Kind of. If all you know is yesterday, today, but today isn't part of the system, then today itself lacks that clear definition needed for robust comparison. It's always just not yesterday and not tomorrow.
This sounds a bit like Augustine wrestling with time in his Confessions.
Absolutely. Augustine's idea of the present as this point without extension separating past and future, that point is like our equality. Without it, time is just this undifferentiated flow.
You also brought Kant into this.
Yeah, Kant's idea of a priori categories, fundamental concepts like identity or sameness that our minds use to structure experience.
Things we bring to experience, not just learn from it.
Right. Kant argued that without concepts like identity, A equals A, we couldn't even perceive order in the sensory chaos. So equality isn't just a useful pause.
It's a prerequisite for understanding any order, a condition for judgment itself.
That's the idea. It's transcendental, in his terms, and equality plays that same foundational role in math.
So translating this back into the math itself, how do A and embody this stopping the clock?
Okay, in wide order, the statement AA is the mathematical representation of that present moment, that pause. It allows A to be comparable to itself.
Without which you couldn't define, say, a closed interval like now.
Exactly. That concept requires the endpoints to be potentially identical.
On strict order.
It models time as just a sequence of non-identical instants.
Okay.
But then you hit a problem. How do you measure duration if no instant is equal to itself? What's your baseline?
There's no fixed tick of the clock to measure against.
Precisely. There's no stable unit.
This seems to lead us right to questions about existence itself. You mentioned Heidegger.
Right. Heidegger's being in the world requires a here and now, that sense of presence. Mathematically, you could say AAA provides that conceptual here, that point of self-reference.
So strict order might describe a world almost without consciousness, without an observer to stop things.
You could think of it that way, a world of pure process where nothing is ever fixed long enough to be observed as itself. Like the early universe after the Big Bang, just expansion. No stable present established yet.
That's a powerful image.
And it highlights a paradox, doesn't it? We use strict order to describe these fundamental processes.
But we can only understand that description because our minds naturally operate with the concept of identity, of wide order.
Exactly. We need those fixed points, those pauses to make sense of the flow. It's like the wind of becoming blows without stopping, but it is the rock of being that tells us where we are.
Which loops us back beautifully to Parmenides and Heraclitus.
It really does. You pointed out how well wide order fits Parmenides' emphasis on stable being.
While strict order perfectly mirrors Heraclitus' focus on becoming, on constant flux.
Yes. Parmenides' being is, reality is stable, hence A makes sense, this rock is itself. Heraclitus, everything flows, reality is change, hence A is false, the river is always becoming other.
And you argue that mathematics, specifically wide order, actually synthesizes these two.
I think it does in a really elegant way. Wide order contains both equality, which is Parmenidean being, and less than, which is Heraclitean becoming.
Okay, so the wide order holds both concepts in tension. Why is that duality so essential?
Well, wide order lets us describe structures that have both hierarchy and identity. like those rankings with ties. The principle is the equal is the foundation, the lesser is the relation.
Equality is the bedrock.
Absolutely. Foundational in logic, AA, the law of identity. Foundational in math, 2 plus 2, 4. And you could argue foundational philosophically being means being equal to oneself.
And strict order, then, its essential role.
It's for pure irreversible change. Causality, cause-effect. Evolution, ancestor-descendant. Thermodynamics, maybe. The key principle is asymmetry. If A, B, then B cannot be less than A. No going back.
This is making me think of Descartes now. Cogito ergo sum.
That's a fantastic connection. There's a real parallel.
How so?
When we state AA in wide order, it's like Descartes saying cogito ergo sum. It's an affirmation of self-identity as a foundational reference point. A is equal to itself, therefore it exists within this relational system.
So Descartes uses thought as the anchor. Math uses equality.
Exactly. Just as Descartes needed the sum, the I am, to ground his philosophy against doubt, mathematics needs to ground order against the potential chaos of pure difference, of only having strict relations.
So it's like the mathematical cogito. AA, ergo A exists.
That's a great way to put it, which leads to a final thought, maybe for you and for everyone listening.
Okay.
What if Descartes had written, ordino ergo sum? I order, therefore I am. Could the very act of imposing order, specifically the wide order, which requires recognizing identity, be itself a fundamental sign of our conscious existence, a proof that we are beings who structure reality?
That's a lot to chew on. It definitely makes you look at an air completely differently.
Right. So to wrap up this deep dive, we've seen how strict and wide orders are more than just math notation. They're packed with philosophy.
They reflect fundamental ideas about change versus stability, becoming versus being. And that little sign representing identity is surprisingly powerful. It's the anchor that lets us make sense of the flow.
It really shows that mathematics can be this incredibly rich language for exploring reality, not just calculating things.
And that final thought about ordino, ergo sum,
Yeah.
it really invites you to keep thinking about the philosophical weight behind even the simplest structures we use.
Yeah, maybe try applying this lens, strict versus wide, to other concepts. We talked about love once. Is it strict? Loving another is different from self-love. Or wide, self-love is a foundation. Lots to explore.
Definitely. Well, thank you for joining us on this exploration.
We hope this deep dive has given you some new perspectives on the hidden depths of mathematics and its connection to how we understand everything.